Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on graph theory, lecture number 27, in which I will discuss on minimal spanning tree, and also I will describe the Kruskals algorithm and Prim's algorithm to find the minimal spanning tree. Now we wish to know what is minimal spanning tree. Let G be a weighted graph. Weighted graph means each edge of the graph is assigned to a non-negative number. Let we have a graph. This is a graph. Here V1, V2, V3, V4 be the vertices, and edges are V1, V2, V2, V3, V1, V3, V4, V3, V4, V1. Each edge is assigned to a non-negative number. Let this edge V1 and V2 is assigned to 2, V3, V2 edge is assigned to 5, this edge is assigned to 4, this edge assigned to 1, this edge assigned to 3, and in this way, if each edge is assigned to a non-negative real number, then this graph is known as weighted graph. We know that weighted graph is a graph. If this is a connected graph, then we may get a spanning tree from this graph. Spanning tree is the skeleton of the graph. We may get different spanning tree of this graph G. Now we use a term, weight of the spanning tree. Weight of the spanning tree of the graph G is the sum of weights of all branches of the spanning tree. If we get different spanning trees from this graph, we get different weighted spanning tree, and the minimum of the weighted spanning tree is called minimal weighted spanning tree. That is minimal spanning tree. Let T be a spanning tree of graph G. Then weight of spanning tree T is the sum of weight of all edges, that is tree branches of spanning tree T. In this way, we may get different spanning tree of this graph G, and minimum weighted spanning tree is called minimal spanning tree of graph G. Now we define minimal spanning tree. Let G be a weighted graph. The weight of spanning tree T of graph G is defined as sum of the weights of all branches of the spanning tree T. Different spanning tree of a weighted graph will have different weight. A spanning tree with smallest weight in a weighted graph is called minimal spanning tree or a shortest spanning tree. Now we describe Kruskals algorithm to find a minimal spanning tree. Let G be a weighted graph with n vertices. We list all edges of the weighted graph in order of non-decreasing weight. Firstly, we select an edge of smallest weight, and then successively we select the new edge of the smallest possible weight that forms no circuit with previously selected edge. Let us continue this process until n minus edges have been selected, and these n minus edges will form the desired minimal spanning tree. As the graph has n vertices and this graph will form a spanning tree having n vertices, will contain n minus 1 edges. With the help of particular example, we may clearly understand the process. Now we take an example. Example is, find the minimal spanning tree for the given graph G with the help of Kruskals algorithm. Here the weighted graph G is given in figure. Now we list all edges of the graph G in order of non-decreasing weight. Here first column is weight and second column is edge. We will list the weight of edges in order of non-decreasing weight. Here we see that we have weight 1, 2, 3, 4, 5, 6, and we write firstly the smallest is 1. Smallest weight is 1, and this weight is for edge V3, V4. And then among the remaining edges, the smallest weight of the edge B2, and this 2 be the weight of edges V1, V3 and edges V5, V6. Then remaining of the edges with smallest weight B3, 3 be the weight of edges V3, V6, V3, V6 and V1, V5. V1, V5. Then remaining edges of smallest weight B4, weight of 4 be the edge of V1, V2, V1, V2. Then remaining edges of smallest weight B5, the weight 5 is for edge V2, V4. Then remaining of the edges with smallest weight B6, 6 be the weight of V4 and V6 and weight of V3 and V5. Now we start to construct the minimal spanning tree with this order. Here firstly we take V3, V4, smallest weight, V3, V4. We write here V3, V4. Then V1, V3. Then V1, V3 like this. V1, V3. Then V5, V6. This V5, V6 here. Then V3, V6 here, V3, V6. Then V1, V5, V1, V5. If we join V1, V5, then it will create a circuit. Here V1, V5, V6, V3, V1. So we will not take this V1, V5. Then V1, V2. V1, V2. Here number of edges be 1, 2, 3, 4, 5. Since we have 6 number of vertices, so we will have to take only 5 edges. Here we get 5 edges. 1, 2, 3, 4, 5. And this is the minimal spanning tree. We have to calculate the weight of this spanning tree as weight of V1, V2, B4, weight of V1, V3, B2, weight of V3, V4, B1, weight of V3, V6, B3, weight of V5, V6 is 2. Therefore, weight of minimal spanning tree equal to 4 plus 2 plus 1 plus 3 plus 2. 4 plus 2, 6, 7, this 10, 12. And this is the minimal spanning tree with weight 12. Our problem is solved. Now we will describe the Prim's algorithm to find minimal spanning tree. Let G be a connected weighted graph with n vertices. Vertices are V1, V2, Vn. Now let us arrange the given weights of the edges of graph G in n by n table. The weight of non-existent edges are taken as infinitive and diagonal elements as empty. Let us start from vertex V1 and connect it to the vertex which has smallest entry in the row 1 of the table. Let this vertex be Vk. Now construct a subgraph with vertices V1 and Vk, and we connect V1 Vk by an edge, that is edge between them. Let us connect this subgraph to a vertex except V1 and Vk that has smallest entry among all entries in rows 1 and row k. Let new vertex be Vi. Now construct a tree with vertices V1, Vk, Vi as a subgraph and continue the process until all n vertices will be connected by n minus 1 edges. And we will understand this idea by a particular example. Let we have an example. Find the minimal spanning tree for the given graph G with the help of Prim's algorithm. Let the given graph be this. This is a weighted graph. Here we see we have 6 vertices and non-negative number is associated with each edge. Therefore, this is a weighted graph. Now we write vertices V1, V2, V3, V4, V5, V6 in topmost row and leftmost column. Now we write the numbers in the table by the process. Since V1 and V1 does not make any edge, so weight of this edge is empty. Here we write dash. Here V1, V2 edge. Here V1, V2 edge. Weight of this edge is 4. We write here 4. Now V1, V3 edge. Here V1, V3 edge. Weight of this edge is 2. Now V1, V4 edge. No single edge between V1 and V4. So we write the weight of this edge is infinitive. Now V1, V5. V1, here V5. Weight of this edge is 3. We write here 3. Now V1, V6. V1, V6 is not directly connected by an edge. So weight of this edge be infinitive. Here V2, V1 edge. V2, V1 edge. Weight of this edge is 4. V2, V2 edge. Here we write empty weight. Here V2, V3. V2, V3 vertices are not connected by directly any edge. So weight of this edge will be infinitive. And similarly we construct this table. Now we start to construct a minimal spanning tree. Firstly, we take vertex V1. Here vertex V1. And we take minimum weight in the first row, 2. So we connect V1 and V3 first. V1 and V3. So we cancel this V1, V3. Here 2 or V3, V1. We cancel these numbers. Now we find the smallest weight in the row of V1 and in the row of V3. Here we see weight 1. That is V3, V4. Now we connect V3, V4. V3, V4 weight 1 and V4, V3 is also weight 1. We cancel this. Now we find the smallest weight in V1, V3 and V4. Here we see smallest 3. Here also 3. So 3 is the smallest weight. We may take V1, V5 first. Since here we get tie, we may choose any of the number V1, V5. Here V1, V5. V5. We cancel V1, V5, 3, V5, V1 also be cancelled. Now we find the smallest weight in the row V1, V3, V4 and V5. In V1 row weight 4, in V3 weight 3 and in V4 5 and 6, here 3 is less, here 2 we get in V5 row. So this is V5, V6. We connect V5, V6. So we cancel this V5, V6, V6, V5. Now we take again smallest number in the row V1 4, in the row V3 3. 3 is the smallest, and here 5 and 6, here 6, here 3, tie. Here 3, this is V3, V6. Here if we connect V3, V6, we get a circuit. We connect V3, V6, V3, V6, V5, V1, V3. This will be a circuit. So we do not take this number. Here we select this number V6, V4. Here V6, V4. Also make circuit. So we will not take this. Next number is smallest number here 4. 4 means V1, V2. Here also 4, V2, V1, and we will not take 3. We will not take 3, this 3 and this 3. So smallest number be 4. Here V1, V2. Here V6, V4. If we connect V6, V4, we will get a circuit, this circuit. So we will take V1, V2. V1, V2. And this will be a spanning tree with 5 edges. Since we have 6 vertices, so we may take only 5 edges for a spanning tree. So this will be the spanning tree. And weight of this spanning tree, we find the weight of this spanning tree. Here weight 4, here 1, here 2, here 3, here 2. Weight equal to 4 plus 2 plus 1, 4 plus 2 plus 1 plus 3 plus 2. This 6, 7, 10, 12. So this is another minimal spanning tree of weight 12. In Kruskals algorithm, we get different minimal spanning tree but weight of that spelling tree is also 12. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.